Alright, so in this problem, I have 2 to the power of x plus 4 to the power of x is equal to 8 to the power of x. So to solve this, I'm going to first rewrite this as 2 to the power of x plus 2 squared to the power of x plus 2 to the power of, is equal to 2 to the power of 3 to the power of x. I rewrote 4 as 2 squared and 8 as 2 to the power of 3. Now I'm going to rewrite this as 2 to the power of x plus 2 to the power of x to the power of 2 is equal to 2 to the power of x to the power of 3. So all I did was I switched the places of these two exponents. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y plus y squared is equal to y to the power of 3. Now if I subtract y to the power of 3 on both sides, instead I'm going to subtract y squared and negative y on both sides. So now I have y to the power of 3 minus y squared minus y is equal to 0. And now if I factor out y, I get y times y squared minus y minus 1 is equal to 0. So this gives me two equations. I have y is equal to 0, which is a solution of y already, and I have y squared minus y minus 1 is equal to 0. And to solve this, I would have to use the quadratic formula, and I'm not going to waste your guys' time by doing all of that, but if I solve this, I should get that y is equal to 1 plus or minus the square root of 5 over 2. So these are two more solutions of y. Now remember how we set 2 to the power of x equal to y. So first off, I have 2 to the power of x is equal to 0. And you can't take 2 to the power of a number and make it equal to 0. So this is wrong, and there is no solution of x here. Now I have y is equal to 1 plus the square root of 5 over 2, and I have y is equal to 1 minus the square root of 5 over 2. So for y equals 1 plus the square root of 5 over 2, I have 2 to the power of x is equal to 1 plus the square root of 5 over 2. And if I take the log on both sides, I have log 2 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move my exponent to the front, so this is equal to b times log a. So in this case, I can move x to the front. So now I have x times log 2 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 2, these two cancel out, and I have x is equal to log 1 plus the square root of 5 over 2 over log 2. Now for y equals 1 minus the square root of 5 over 2, well, 1 minus the square root of 5, that's going to be negative, and you can't take 2 to the power of x and make it a negative number, so this is wrong. So my only solution is right here. Alright, so in this problem, I have 21 to the power of 63 over 63 to the power of 21. So to solve this, I'm going to first rewrite this as 21 to the power of 63 over 3 to the power of 21 times 21 to the power of 21. Now, this is the same thing as 1 over 3 to the power of 21 times 21 to the power of 63 minus 21. Because if I have something in the form a to the power of m over b to the power of m, a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, I had 21 to the power of 63 over 21 to the power of 21. So I rewrote this as 21 to the power of 63 minus 21. Now, 21 to the power of 63 minus 21, that's the same thing as 21 to the power of 42. Now I have this over 3 to the power of 21. Now, 21 to the power of 42, that's the same thing as 21 to the power of 2 to the power of 42. This is 2 to the power of 21. And 21 squared, well, that's the same thing as 21 times 21. So I have this to the power of 21 over 3 to the power of 21, which is equal to 21 times 21 over 3 to the power of 21. Now 21 divided by 3 is 7, so I have 7 times 21 to the power of 21, which is equal to 147 to the power of 21. Now I actually have a second method of solving this problem. So again, I first start with 21 to the power of 63 over 63 to the power of 21. Now this time, I'm going to rewrite 21 to the power of 63 as 21 to the power of 3 to the power of 21. Now I have this over 63 to the power of 21. And now this is equal to 21 times 21 times 21 to the power of 21 over 63 to the power of 21, which is equal to 21 times 21 times 21 over 63 to the power of 21. Now this is the same thing as 21 over 63 times 21 times 21 to the power of 21. 21 over 63 is 1/3, so I have 1/3 times 21 times 21 is to the power of 21. 1/3 times 21 is 7, so I have 7 times 21 to the power of 21, which is again 147 to the power of 21. Alright, so in this problem, I have x to the power of 3 is equal to -8. So to solve this, I'm going to first start by adding 8 on both sides. So then I have x to the power of 3 plus 8 is equal to 0. Now I'm going to rewrite 8 here as 2 to the power of 3. So now I have x to the power of 3 plus 2 to the power of 3 is equal to 0. Now if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. In this case, a is equal to x and b is equal to 2. So now I have x plus 2 times x squared minus 2x plus 2 squared, which is 4. This is equal to 0. So now this gives me two equations. I have right here x plus 2 is equal to 0, and I have over here x squared minus 2x plus 4 is equal to 0. So to start, I'm going to first solve x plus 2 equals 0, which is a simple equation. All I have to do is subtract 2 on both sides, and I get x is equal to -2. So this is one solution of x. Now to solve x squared minus 2x plus 4, I can do this in two ways. So my first method is the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is -2, and c is 4. So I have -2 plus or minus the square root of -2 squared minus 4 times 1 times c, which is 4, all over 2a. Now this is equal to 2 plus or minus the square root of 4 minus 16 all over 2, which is equal to 2 plus or minus the square root of -12 over 2. And the square root of -12, that's equal to the square root of 12 times the square root of -1 over 2. And the square root of 12, that simplifies to 2 plus or minus 2 root 3. And the square root of -1, that's simply I. So I have this over 2. Now if I divide both sides by 2, I get 1 plus or minus the square root of 3i. So these are my two solutions.